Hi everyone. So today we're going to be doing lesson 3.4, which is simplifying algebraic expressions with exponents. There's a handout on Teams that you should print off and fill out as you watch this video. So first we're going to start by recalling all the exponent laws. So this is just a chart on your handout. You don't have to write anything down. It's just to so we can remember all the things we learned last week. So first of all, the multiplication exponent rule. So that says that when I multiply two numbers with the same base, I can add their exponents. The division rule says that when I divide two numbers with exponents that have the same base, I can subtract their exponents. The zero rule says that anything to the power of 0 equals 1, and that's because when you divide anything by itself, that's equal to 1. If I have a negative exponent, I just use the reciprocal with a positive exponent. The power of a power rule. The first example there where I have a to the power of m all to the power of n, I multiply the exponents. The second example, I am applying the outside exponent to each term inside the bracket. And the third one there, where I have a fraction, the exponent is applied to the numerator and the denominator. And then the rational exponent tells me that when I have an exponent that's a fraction, like x to the power of a over b, I will be taking the b root of of x, and then putting that all to the power of a. Okay, now let's put some of this into practice. So, examples: expand and simplify and leave no negative exponents in the final answers. So, number 1. 16x to the power of 5 times 243x to the power of 10 divided by 6x cubed all to the power of 3. So the first thing I'm going to do is get this 3 into that entire bracket. As I do that, I'm also going to do some of this multiplication on the top here. So I'll do 16 times 243 and x to the power of 5 times x to the power of 10. So 16 times 243. Now, when I have x to the power of 5 and x to the power of 10, those are two numbers with the same base that are being multiplied together, which means that according to the multiplication rule, I can add their exponents. So I'm going to have x to the power of 5 plus 10. Now my denominator is 6x cubed all to the power of 3. So that 3 is applied to the 6, so 6 cubed, and x cubed cubed. Now that's a power of a power, so that means I multiply those two exponents, so that will be x to the power of 9. Now 16 times 243 is 3,888, and x to the power of 5 plus 10 is x to the power of 15, divided by 6 cubed, which is 216, and x to the power of 9. Now, I can do 3,888 divided by 216, which is 18, and then using the division rule, I can do x to the power of 15 divided by x to the power of 9, in which case I would subtract those exponents. So now I'm left with x to the power of 15 minus 9 equals 18 times x to the power of 6. And that's simplified. Number 2. 17t to the power of negative 3. The important thing here is that there's no brackets. So the 17 has no extra powers. The power is just 1. We don't apply that power of negative 3 to the 17 because it's not in brackets. So I'm going to simplify the t to the negative 3 to get rid of that negative bracket. I'll do 17 times 1 over t all cubed equals 17. 1 cubed is still 1, and the denominator would be t cubed. 17 times 1 is 17 over t cubed. Number 3. 2 to the power of a plus 3 times 2 to the power of 3a minus 2 times 2 to the power of a plus 3 squared divided by 2a times 2a to the power of 5. Okay, so I'm first going to start by getting this exponent of 2 into that bracket and this exponent of 5 into this bracket. So 2 to the power of a plus 3 times 2 to the power of 3a minus 2 times 2 to the power of 2a plus 6, because a plus 3 times 2 is 2a plus 6. Divide that by 2a times 2 to the power of 5 times a to the power of 5. Now I can add these exponents together because they all have a base of 2. So I'll have 2 to the power of a plus 3 plus 3a minus 2 plus 2a plus 6 divided by, and I'm also going to add the exponents on the bottom here, so you have to imagine a 1 and a 1, and then I have 1 plus 5 is 6, so 2 to the power of 6 times a to the power of 6. I'm going to simplify my numerator, so I have a plus 3a is 4a, plus 2a is 6a, and then I have 3 minus 2 is 1, plus 6 is 7, divided by 2 to the power of 6 times a to the power of 6. Now, because this exponent has a base of 2 and so does this one, I can subtract them because of the division rule. So I have 2 to the power of 6a plus 7 minus 6 divided by a to the power of 6 equals 2 to the power of 6a plus 1 divided by a to the power of 6. And that's simplified. All right, number 4 is c to the power of 4 times d squared all to the power of 3 divided by c squared times d cubed times e to the power of negative 1 all squared. So first we're going to apply those outside exponents inside the bracket. So I have c to the power of 4 times 3, which is 12, times d to the power of 2 times 3, which is 6, divided by c to the power of 2 times 2 is c to the power of 4, times d to the power of 3 times 2, which is d to the power of 6, times e to the power of negative 1 times 2, which is negative 2. Now, using the division rule, I can I can subtract exponents from things that have the same base. So that would be c to the power of 12 minus 4 times d to the power of 6 minus 6 divided by e to the power of negative 2 equals c to the power of 8 times d to the power of 0 divided by 1 over e squared equals c to the power of 8. Now d to the power of 0 is equal to 1, so I don't even need to write that, divided by 1 over e squared. When I divide a fraction, I can multiply by the reciprocal, so I'm going to multiply by e squared over 1 equals c to the power of 8 times e squared. Number 5. The fifth root of x to the power of 1/2 times the square root of x cubed divided by the square root of x all squared. Okay, so this looks really complicated, but the first thing I'm going to do is to get all the exponents into fraction form. So, get rid of all those square root signs. So, this 2 and this 5 become to the power of 2/5. X to the power of 1/2 can stay that way. The square root of x to the power of 3 is the same as x to the power of 3 over 2. And the square root of x is the same as x to the power of 1/2. Now, I'm going to simplify the exponents inside the bracket so I have the same base all around. So in the numerator, I'm going to add those exponents. So now I have x to the power of 1/2 plus 3/2 divided by x to the power of 1/2, all to the power of 2 over 5. 1/2 plus 3/2 is 4/2. X to the power of 4 over 2 divided by x to the power of 1 over 2, all to the power of 2 over 5. Now I can subtract the exponents inside the bracket because they have the same base. So I have 4 over 2 minus 1 over 2, which is 3 over 2. Now I have a power of a power because I have x to the power of 3/2, all to the power of 2/5. When I have a power of a power, I can multiply. So I have 3 over 2 times 2 over 5, which equals x to the power of 6 over 10, which is equal to x to the power of 3 over 5. Number 6. 5x cubed y squared divided by 3xy to the power of 5 times 6x squared y cubed divided by 25xy squared. All right, so I'm going to simplify this by first multiplying across the numerators and across the denominators. So I'll have 5 times 6, which is 30. Then I'll have x cubed times x squared, in which case I can add their exponents. So I have x to the power of 5. Then I have y squared times y cubed, add the exponents, and I have y to the power of 5. In the denominator, I have 3 times 25, which is 75. Then I have x times x, which is x squared. And then I have y to the power of 5 times y to the power of 2, which is y to the power of 7. Now I'm going to simplify. So what can I divide 30 and 75 by? I could divide them both by 15. So 30 divided by 15 is 2. 75 divided by 15 is 5. So that will simplify to 2 on the top and 5 on the bottom. Then I have x to the power of 5 and x to the power of 2, which I can subtract. So that will leave me with x to the power of 3. And then I have y to the power of 5 minus y to the power of 7, which is y to the power of negative 2, equals 2 over 5 x cubed times 1 over y squared equals 2x cubed over 5y squared. All right, number 7. X to the power of a squared divided by x to the power of a plus b times xb to the power of 2 divided by x to the power of b plus c times x to the power of c squared divided by x to the power of c plus a. So just like I did in the last one, I'm going to simplify across the numerator and simplify across the denominator. So multiply through. So I need to simplify these power of powers first. So I'll have x to the power of 2a. times x to the power of 2b times x to the power of 2c divided by, now in the denominator, I can add the exponents because I'm multiplying the same base. So I have x to the power of a plus b plus b plus c plus c plus a. Now I'm going to add the exponents in the numerator. So x to the power of 2a plus 2b plus 2c divided by x to the power of, now I'm going to simplify, a plus a is 2a, b plus b is 2b, c plus c is 2c. Now I have the same numerator as I have denominator, which is equal to 1 when I divide. When you divide anything by itself, it's equal to 1. Or x to the power of 0, and then equal to 1. Number 8. A over b to the power of x times b over a to the power of y times ab to the power of x minus y. So let's get those exponents into the fractions. So I'll have a to the power of x over b to the power of x times b to the power of y over a to the power of y times a to the power of x minus y times b to the power of x minus y. Now I'm going to simplify the numerator by adding the exponents on the a's. So now I have a to the power of x plus x minus y, and then I'll have b to the power of y plus x minus y. And the numerator, I still have bx times ay. Now I'll just simplify those exponents there, so I'll have a to the power of 2x minus y, and b to the power of y minus y is 0, so just x, divided by bx times ay. Now I'm going to subtract exponents as I divide, so I'll have a to the power of 2x minus y, and then minus this y here, times b to the power of x minus x equals a to the power of 2x minus 2y times b to the power of 0, equals a to the power of 2x minus 2y. Number 9. 64 to the power of 5/6 times 16 to the power of negative 3/4 divided by 9 to the power of 3/2. So I have 64 to the power of 5/6 times 16 to the power of negative 3/4, all divided by 9 to the power of 3/2. Now, I'm going to break these down as much as I can. So 64 to the power of 5/6 is the same as the 6th root of 64, all to the power of 5, times, so for this next one, I'm just going to get rid of that negative sign. So I'm going to do 1 over 16 to the power of 3/4, divided by 9 to the power of 3/2 is the same as the square root of 9, all cubed. All right, so let's work with this one first. So the 6th root of 64, do that on your calculator, equals 2, and then it's all still to the power of 5. Now, 1 over 16 to the power of 3/4 is the same as the 4th root of 1 over 16, all cubed. And the square root of 9 is 3 cubed. Equals 2 to the power of 5 is equal to 32. The 4th root of 1 over 16, so you would do the 4th root of 1, which is still 1, and then you do the 4th root of 16, which is 2, and that would all be cubed, over 3 cubed is 27, equals 32 times 1 over 8, all divided by 27. But when we divide by 27, we could multiply by the reciprocal, which would be 1 over 27. And then I can do some simplifying. Divide these both by 8, so 1 and 4. And I'm left with 4 over 27. All right, the next section here says to solve. So solve means find the value of the variable that makes the equation a true statement, where the left side equals the right side. So number 10, m cubed times m squared equals 3,125. So of the m's, I can add their exponents because they're multiplied together. So I have m to the power of 5 equals 3,125. So now what's the value of m? I'll take the fifth root of both sides. So m equals the fifth root of 3,125. Do that on your calculator, and that is 5. Number 11, m to the power of 7 over m to the power of 6, all squared equals 196. So power of a power means m to the power of 7 to the power of 2 is m to the power of 14. M to the power of 6 all to the power of 2 is m to the power of 12 equals 196. Subtract the exponents because they're divided, which leaves me with m squared equals 196. Take the square root of both sides. M equals the square root of 196. M equals 14. And number 12, 1 over 16 to the power of 1/4 minus the third root of 8 over 27 equals the square root of x squared. So 1/16 to the power of 1/4 is the same as the fourth root of 1 over 16 minus the cubed root of 8 over 27. So that would be the cubed root of 8 over the cubed root of 27 equals the square root of x squared. That would be the same as saying x to the power of 2 over 2, which is x to the power of 1, which is really just x. So I'm just going to get rid of that there. So it just equals x. The fourth root of 1 over 16 is the same as the fourth root of 1 over the fourth root of 16 minus the cubed root of 8 is 2 and the cubed root of 27 is 3 equals x. The fourth root of 1 is 1, the fourth root of 16 is 2. So 1/2 minus 2/3 equals x. Common denominator of 6 would be 3/6 minus 4/6 equals x. Negative 1/6 equals x. All right, so that's the lesson. So just let me know if you have any questions, and I hope to hear from you soon, and good luck.